Hi guys, and welcome once again to Curated Logic, where we try and up your brain game. Today, we are back in the maths corner. I am always on the hunt for new maths puzzles and problems to try my hand at, just to see how much I still remember from my schooling days. One of my favourite places to look for these questions is on old or current high school or university papers and exams. And the other day, I stumbled across a list of problems that were claimed to be the hardest ever on the SATs. So I thought I'd give them a go. Although not all of the questions were actually difficult, they were for the most part fun to do. And the one I present to you today was perhaps the most satisfying out of the whole bunch. The question presented was as follows. If 3x take y equals 12, what is the value of 8 to the power of x over 2 to the power of y? Now, in addition to the question, 4 multiple choice answers were presented, one of which was there is not enough information to solve this question. Seeing this, I decided not to reference the other potential answers on the off chance that they gave me a hint, and just decided to see whether I could work out if the equation was solvable just from the question alone. So, give the video a pause now if you want to try and work it out on your own. Otherwise, let's see how I went. Okay, so the first thing I began to do was look at the equation presented. I started to play with representing x in terms of y and vice versa, but very quickly worked out that there is in no way this was going to assist me. So, I moved my attention to the second part of the question. Let's take a look at that in isolation. 8 to the power of x divided by 2 to the power of y. The only way I could see this being helpful was if I somehow simplified this. Now, if you are mathematically inclined, which if you are watching this video, I assume you probably are, there is something about this expression that strikes as immediately able to be simplified. When dealing with a group of indices, it is always good to try and make the bases of each element the same. In this case, as 2 is the lower of the two bases presented, if possible, it is worth trying to make the 8 represented as a power with base 2. In this case, 8 is of course 2 to the power of 3. This means we can rewrite the expression as 2 to the power of 3, all in brackets, all to the power of x, still divided by 2 to the power of y. From here, things start to take shape as we apply basic rules of powers. Firstly, when a power becomes itself the base of a larger power, the two exponents used in the expression can simply be multiplied together to form one exponent. Thus, the numerator in the expression changes from 2 to the power of 3, all to the power of x, to 2 to the power of 3x. This is where, if you are paying attention, you will notice something special. Disregarding the minus in front of the y in the original 3x take y equals 12 equation, the two exponents used in the now simplified expression are equivalent to the variables in the original equation, 3x and y. This shows that we are possibly onto a winner. But there is one more step that not only simplifies the expression further, but also reveals the negative missing from in front of the y. As you probably know, another rule with powers is that if a power is divided by another power with the same base, the dividing power's exponent can be simply subtracted from the exponent of the power being divided, to be left with just one power. In other words, here, as both powers are base 2, we can simply minus the y of the denominator's exponent from the 3x of the numerator's exponent, and then do away with the denominator altogether. This leaves us with 2 to the power of 3x take y, which, as you can see, is the left-hand side of the original equation. Therefore, as this equation tells us that 3x take y equals 12, we can confidently say that 8 to the power of x divided by 2 to the power of y equals 2 to the power of 12, or 4096. So, thanks to having the original equation, the expression given is indeed solvable. How did you guys go? As said at the beginning, this wasn't the hardest of all questions, but I think it is likely not usually immediately understood how to proceed, hence why I rated it a 3 out of 5 for difficulty. Let me know how you went in the comments below, and please feel free to submit any math challenges you have come across you think would be fun for me to try and complete here on Maths Corner. You can submit them to info@curatedlogic.com. Also, if you enjoyed the video and want to see more of Maths Corner, please like and subscribe. And if you want to continue upping your brain game, you can follow Curated Logic on any of the socials listed below, on which you can find more riddles and fun. Or you can support us through Patreon, which is also linked below. I hope wherever you are in the world, you are keeping safe and happy. Until next time, keep upping your brain game and have fun. See ya.